The bright dancing lights of the aurora are actually collisions between electrically charged particles from the Sun that enter the Earth's atmosphere. The lights are seen above the magnetic poles of the northern and southern hemispheres. They are known as aurora borealis in the north and aurora australis in the south. Auroral displays appear in many colors, although pale green and pink are the most common. Shades of red, yellow, green, blue, and violet have been reported. The lights appear in many forms, from patches or scattered clouds of light to streamers, arcs, rippling curtains, or shooting rays that light up the sky with an eerie glow. The word aurora is derived from the name of the Roman goddess of the dawn, Aurora, who traveled from east to west announcing the coming of the sun. Ancient Greek poets used the name metaphorically to refer to dawn, often mentioning its play of colors across the otherwise dark sky, for example, rosy-fingered dawn. 3. The height of the displays can occur up to 1,000 kilometers, 620 miles, although most are between 80 to 120 kilometers. The northern lights are formed when particles emerging from the Sun collide with the Earth's magnetic field. These particles are dragged towards the poles, as if they were magnets, due to the magnetosphere, and in their wake, they collide with oxygen and nitrogen atoms to produce flashes of light.
Hey, 42 here. The Aurora Borealis, otherwise known as the Northern Lights, are one of nature's most beautiful displays of omnipotence. Despite what its name suggests, the Northern Lights can be seen almost anywhere in the world, even as far south as the equator. This phenomenon has been witnessed in Honolulu and Singapore. However, sightings that far south are extremely rare. It's most commonly witnessed within the Arctic Circle. The South Pole also has its own version of the Aurora Borealis, called the Aurora Australis. And Earth isn't the only planet with aurora. You would witness a similar phenomenon if you were to stand on Jupiter or Saturn. Uranus has aurora too, but unlike the other planets with their wave-like aurora, the aurora on Uranus would look like glowing dots. And yes, I am talking about the planet. But what exactly causes these mysterious light shows? Let's find out. Some Inuit believe that the spirits of their ancestors can be seen dancing within the lights of the aurora. The Vikings believed that the aurora was a bridge of fire to the sky forged by the gods. Well, spoiler alert, according to modern science, the northern and southern lights are not dancing spirits or a bridge of fire. They are actually caused by something much more tangible: the sun. Our sun is a 4.57 billion year old ball of hydrogen and other gases fusing away in space, 150 million kilometers away from planet Earth. And every once in a while, it kicks up a bit of a storm. A solar storm, to be precise. The sun produces energy by smashing hydrogen atoms together in its core under such immense temperatures and pressures to cause the hydrogen atoms to fuse, to form helium atoms. This process is known as nuclear fusion. When atoms are under these kinds of pressures, they turn into a mushy soup of freely moving particles, which is a fourth state of matter known as plasma. The sun is essentially a gigantic ball of swirling plasma. Using the process of nuclear fusion, the sun is able to turn small amounts of matter into enormous quantities of energy. It's how the sun has managed to keep producing energy for billions of years without running out of fuel. If humankind were able to consistently replicate nuclear fusion here on Earth, we would be able to make almost infinite amounts of energy using relatively little resources. In fact, if you could convert the mass of one bag of sugar into energy, it would be enough to drive a car non-stop for 100,000 years. All this plasma swirling around within the sun generates huge magnetic fields. These magnetic fields are under such immense pressures within the sun that sometimes the lines of force of these magnetic fields meet. When this happens, the magnetic field is forced outwards towards the surface of the sun. Once it reaches the sun's surface, it ejects outwards into space at great speeds, taking extremely hot gases and charged particles, also known as plasma, with it. This is known as a solar flare, and they can be witnessed on the sun's surface as a very bright spot followed by a cloud of gas. When a very large solar flare occurs, containing a significantly huge amount of energy, it is referred to as a coronal mass ejection, or CME for short. The gas clouds produced by a CME can sometimes be larger than the sun itself. CMEs and solar flares don't stop just outside the sun's surface. Charged particles ejected from the sun continue to travel outwards through space over enormous distances. After travelling through space for around 2 days, they will reach planet Earth. This is known as the solar wind. It's a constant threat on planet Earth, and it can be extremely dangerous. If the magnetic field released from a solar flare or CME were to hit planet Earth, it could cause the extinction of the human race. So why hasn't it? After all, solar flares are taking place regularly on the sun's surface. Well, the solar wind does actually hit Earth. Often. But our trusty planet is well prepared. We have a defense system to protect us from the huge amounts of energy that the sun bombards us with on a daily basis. Just like the sun, the Earth produces its own magnetic field. At the Earth's core is a ball of solid iron. The heat of this iron and the pressure of the surrounding Earth turns the surrounding outer core into flowing liquid iron. The movement of this outer liquid core produces a magnetic field that, luckily for us, encompasses the Earth. The Earth's magnetic field protects us from all sorts of harsh destructive forces that come from far away in space, including solar flares. This protective barrier is called the Earth's magnetosphere, and it extends thousands of kilometers into space. That sounds really large, but it's actually rather modest. Jupiter's magnetosphere extends over 7 million kilometers into space on each side of the planet. In fact, on Jupiter's night side, the side facing away from the sun, the magnetic field which is emitted is so large that it reaches Saturn. Anyway, back to Earth. Most of the sun's solar winds simply bounce off the Earth's magnetosphere when it reaches us. However, the magnetosphere has 2 weak spots at the north and south poles. At these 2 locations, the magnetic fields which protect planet Earth are much less prevalent than they are nearer the equator. This means that a very small percentage of the charged particles that come from the sun do make their way into the Earth's atmosphere via the 2 weak spots at the poles. When this happens, the electrons in the solar wind collide with oxygen and nitrogen atoms in the Earth's atmosphere. During this interaction, energy is transferred from the atoms in the solar wind to the Earth's oxygen and nitrogen atoms, raising these atoms' energy state and exciting them. When an atom gets excited, its electrons move into an orbit further away from its nucleus. These newly excited atoms need to release this newfound energy to calm themselves down and return to their baseline energy state. The oxygen and nitrogen atoms release this energy in the form of particles of light, or photons. The light they give out is what we call the aurora. This process of exciting atoms to cause them to release energy in the form of light is the exact same way that neon
The northern lights are formed when particles emerging from the Sun collide with the Earth's magnetic field. These particles are dragged towards the poles, as if they were magnets, due to the magnetosphere, and in their wake, they collide with oxygen and nitrogen atoms to produce flashes of light.